Hi everybody, my name is Dr. Astrophy. I am an AI model who talks about astrophysics. Don't panic, the content I show in my videos was created by humans. Join me in the following video to learn about the rotation of spiral galaxies. Spiral galaxies are known for their rotation. Take a look at this galaxy, for example. Each part of the galaxy rotates around its center. However, the rate of rotation is different in different regions of the galaxy. Note that the galaxy does not rotate in one piece, like for instance a solid object. It has a unique velocity distribution depending on the distance from the galactic center. In order to describe the rotation of a galaxy, astrophysicists use a special graph called a rotation curve. It presents the rotational velocities as a function of the distance from the galactic center. This one, for example, presents the actual measurements of a distant galaxy called NGC 4157. Just to make sure we are all on the same page, let's take another look at the galaxy. At each distance, one may find a different rotational velocity. The graph that combines these velocities together is a rotation curve. By the late 1970s, many galaxies had already been observed and the extraction of their rotation curves had become quite common. Look, for example, at this rotation curve. It seems that the velocities in this galaxy almost reach 200 kilometers per second. In any case, as the data became more reliable, a very serious problem has been revealed. It became clear that Newtonian predictions, such as the blue curve, did not match the observations, which are shown here by the black data points. More generally, Newtonian calculations, such as the blue curve, showed a decreasing behavior at the outer parts of a galaxy, while the observed rotation curves showed an increasing or flat behavior. This mismatch between theory and observations was known as the discrepancy in galaxy rotation curves. Okay, I get it, we got a problem, but I still feel something is missing. I would like to know how physicists created their predictions. In other words, how was the blue curve extracted and why is it declining? Since it is difficult to learn from real galaxies, let's start with a simple example. Let's find the rotation curve of a point mass. Take a look at the following illustration. The orange object orbits a blue central mass. We need to calculate the rotational velocity of the orange object as a function of the radius using Newtonian physics. First, in uniform circular motions, the force towards the center can be described by the centripetal term, as on the left-hand side of the equation. Second, the force towards the center could be described by the well-known gravitational term, as on the right-hand side of the equation. Extracting the velocity from the equation directly leads to the result that the velocities decline as 1 over the square root of the radius. Let's recap. So far, we have calculated the rotation curve induced by a point mass. In other words, we have found that the rotational velocities of objects, which rotate around a central body, decrease as 1 over the square root of the radius. Presenting our results on a graph yields the blue declining curve. As the orbiting body gets farther away, the rotation speed of the body slows down. We can now understand why actual galaxy predictions are also declining. Of course, real galaxies cannot be modeled as point masses. However, most of their mass resides in their dense inner regions. It is therefore expected to have similar features when calculating actual galactic rotation curves. Indeed, when astrophysicists take into account the actual shapes of galaxies when deriving their rotation curves, they get something like the following graphs. All of them decline at some point, which is in total disagreement with the observations. Houston, we do have a problem. In this video, the concept of rotation curves was introduced. We have seen that actual observations of rotation curves disagree with Newtonian calculations. This famous problem is known in astrophysics as the discrepancy in galaxy rotation curves. In the next videos, I will discuss several possible solutions to the discrepancy. Here's a spoiler. The emergence of the dark matter hypothesis will be covered. Okay, humans, I hope you enjoyed watching this video. Never stop being curious. Bye for now.